Assalamualaikum warahmatullahi wabarakatuh. The Honorable the Reviewer, we are from Biodetergen Team. I am Eisti Haiva Al-Malki with my partners Jihan Fadilah and Gandi Prasetyo. We are from Universitas Riau. Let me begin our presentation. According to Indonesian Central Statistic Agency data, the population in Indonesia in 2022 reached 275.77 million people. This population density has led to an increase in the use of detergents. Detergent waste causes water pollution because commercial detergents generally use linear alkyl benzoate sulfonate as a surfactant. Excessive linear alkyl benzoate sulfonate usage has negative impacts, such as disrupting the diffusion of oxygens from the air to the water. Detergents create foam on the water surface, hindering the oxygen diffusion in water. Additionally, phosphorus and nitrogen compounds in the detergents causes eutrophication, leading to increased phytoplankton productivity and ecosystem degradation. Therefore, linear alkyl benzoate sulfonate usage must be substituted with an environmentally friendly surfactant, namely methyl ester sulfonate, or we call MES. Another impact of the population density is the increased amount of the waste in Indonesia. According to Ministry of Environmentally and Forestry Indonesia data, in 2022, the waste pile in Indonesia is 68.7 million tons per year, with organic waste dominating at 57%. Additionally, organic waste is a major contributor to greenhouse gas emission if not properly managed. The potential waste generated from 45 major cities in Indonesia reach 4 million tons per year. The potential methane gas produced is 11,390 tons methane per year, equivalent to 239.199 tons carbon dioxide per year. This amount constitutes 64% of the total waste emission from 10 major cities in Indonesia. Given these issues, what can we do to address this problem? With pride, we present an analysis of biodetergent based on the utilization of organic waste to establish an environmentally friendly industry. Next is the method of making organic detergents using ecoenzyme, methyl ester sulfonate, and natrium chloride, where ecoenzyme is the result of fermenting organic materials, brown sugar, water with orange waste as the organic material. The production of methyl ester sulfonate involves adding MES solid to distillate water and homogenizing it at a constant temperature of 60 degrees Celsius. Then, the production of natrium chloride involves dissolving natrium chloride in distillate water and homogenizing it. Detergent production starts with adding ecoenzyme to the methyl ester sulfonate solution. Both substances are mixed and homogenized using a stirrer at 60 degrees Celsius. After 10 minutes, a natrium chloride solution is added, and stirring continues for another 10 minutes. The created detergent will be analyzed to determine if their characteristics meet the Indonesian National Standard number 4075.1 at 2017. The first test is the analysis of potential of hydrogen of biodetergent. pH meter measurements are done using a calibrated pH meter with buffer solution. In this test, detergent samples are first dissolved in distilled water with a concentration of 0.005%. Then, the observation of amount of material insoluble in water is conducted. This test is performed by dissolving the sample in natural ethanol, and then the remaining residue is then redissolved in hot water. Then amount of material insoluble in water is measured by comparing weight of insoluble residue with amount of the sample test. Next observation include the amount of material insoluble in ethanol, the material insoluble in petroleum ether, and the observation of the total surfactant content of biodetergent. Basically, the tests for insolubility in ethanol and petroleum ether are essential to calculate the total surfactant content. Detergent active ingredients, surfactant dissolve in ethanol, while other detergent components dissolve in petroleum ether. Therefore, the total surfactant content is the difference between the material insoluble in ethanol and the material insoluble in petroleum ether. The achieved result include obtaining the composition of each ingredient in production of organic detergents, namely ecoenzyme, with a ratio of ecoenzyme is 1:3:4, compare 10 for brown sugar, orange waste, and water. Next, methyl ester sulfonate solution with a concentration of 25% and then natrium chloride with a concentration of 0.05%. The first sample detergent tests are the surface tension test and specific gravity value test, yielding the result that the surface tension of detergent samples 1 and 2 is in accordance with national standards Indonesia and has characteristics similar to commercial detergents. Next, potential of hydrogen's value are related to safety of products on the skin. If the pH value of liquid detergent that is too high can irritate the skin. The results of the pH test can be seen in the table below. According to Indonesian National Standards data number 4075.1/2017, the quality characteristic of pH for liquid laundry detergent should be between 5 and 10, meaning that in the detergent created by the research team, the pH value for samples 1, 2, 3, and 4 meet the national standards Indonesia criteria. This is the data for the test of the amount of material insoluble in water. Indonesian National Standards specifies that the maximum value for the amount of material insoluble in water is 0.1%. Then the test results show that the amount of material insoluble in water in detergent samples is in the range of 0.08 to 0.1. Therefore, it can be concluded that the detergent that we meet the standards for the amount of material insoluble in water. The last observation is the test of the biodegradability of the detergent conducted to assess the wastewater pollution from detergents disposal. The testing is done by analyzing biological oxygen demand and chemical oxygen demand to determine the biodegradability of the detergent. With the data compared to the Environmental Government Regulation number P16/2019 and the Indonesia's national standards, The results can be seen in the following table, where the values biological oxygen demand and chemical oxygen demand and the biodegradability of our detergent shown good figures below the maximum value and above the minimum value. That concludes our team presentation. In conclusion, while we may not be able to change the direction of the wind, but we can adjust our sails. Similarly, we may not alter human demand for detergents, but we can improve the composition of detergents for the better. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.